an alternative technology for management of municipal solid waste, specifically for the organic fraction of solid waste. The feeding capacities of the bioreactor are 500 kg per day or 1000 kg per day. This figure shows the schematic diagram of a stirred tank bioreactor. Inside the bioreactor are paddles for mixing the materials. Rotation of the paddle is quite slow, that is, 4 revolutions per hour, and driven by 1/4 horsepower motor. Organic waste or feedstock is loaded on the top opening port. Through the paddle, materials slowly move into the opposite end where raw compost is discharged. The harvested raw composts are then transferred to the curing area for further degradation and maturation. Here is the composting process using the bioreactor technology. First is material or feedstock preparation, where shredding of organic waste, weighing, and mixing of materials are done. Next is the in-vessel composting using the bioreactor. The composting operation using the bioreactor is continuous. This means daily feeding of organic waste and daily unloading of raw compost. Raw compost harvest is about 50% of the total load. This raw compost is then transferred to the curing area for further degradation and maturation for a minimum of 30 days. Curing piles should be regularly turned and temperature is also monitored. Finally, mature composts are then sieved and packed. Here's the recommended proportion of organic materials for composting. 1 part dry waste and 2 parts wet waste. Dry wastes, or the browns, serve as carbon source needed by decomposers or the microorganisms responsible for decomposition of organics wastes. While wet wastes, or the greens, serve as nitrogen source for decomposers. These materials are both needed for optimum composting activity. So, for a 500 kg per day bioreactor capacity, you need a daily loading of about 170 kg of dry waste and about 330 kg of wet organic wastes. For a 1 ton per day capacity bioreactor, you will need a daily input of about 330 kg of dry wastes and about 670 kg of wet waste. You can try this proportion initially, but you can also try 1:1, or 1 part dry waste, and 1 part wet waste, depending on the type of waste materials you have. Here are examples of dry materials or browns. Dried yard waste such as fallen leaves, dry plant cuttings, or dry grass clippings. Sawdust, cocoa peat or core dust, and agricultural wastes, such as rice straw, sugarcane bagasse, corn cobs, etc. Wet wastes or greens include kitchen waste such as vegetable scrap, fruit peelings, and leftover food. Market waste such as vegetable scraps. And food processing wastes. You can also use fresh garden wastes, as well as fresh agricultural or farm waste as wet wastes. If available, nitrogen-rich sources can be added in the wet materials. Nitrogen-rich wastes include livestock waste such as manure from poultry, piggery, horse, and dairy farms. This should be added in moderation in the composting mixture. About 10% of the total mixture is recommended if available. Also high in nitrogen level are fish wastes, and green materials such as fresh grass clippings, legumes cuttings, weeds, etc. Composting materials, that is, wet and dry wastes, should be shredded prior to loading into the composting unit. Small particle size of waste materials will allow faster decomposition during composting. Once all the raw materials for composting are prepared, weigh and mix the shredded wet and dry wastes. The moisture content of the initial mixture should be 50 to 60%. This is considered to achieve the optimum moisture content for compost decomposers. Moisture content of the initial mixture can be determined through a simple method called squeeze test. First, get a handful of the mixture, then squeeze. If while squeezing, water drips heavily, it means your mixture is too wet or the moisture content is more than 60%. You can resolve this by adding more dry materials to your mixture. If little amount to almost no water drips when you squeeze, open your hand. If the mixture in your hand forms or clumps into a ball and retains that shape, then the moisture content is just right. You have achieved 50 to 60% moisture content. However, if the mixture crumbles or breaks when you open your hand, it means the mixture is too dry. Add more water or wet materials to the mixture until you achieve the right moisture level. After preparing the right mix, the materials are then loaded into the bioreactor at the top feed port. Loading is staggered to avoid choking the unit. Raw compost is slowly discharged at the opposite end port. In one day, you can harvest about 50% of the total materials loaded. Harvested raw composts are transferred to the curing area. Remaining organic matter are further degraded during the curing phase, therefore, increase in temperature can be observed during curing due to microbial activity. Regular turning of piles, and monitoring of temperature and moisture should be done during the curing stage. After the curing stage, final product is then sieved and packed. Label the compost and store in dry, covered area. Compost is mature and ready for use when the temperature in the pile has dropped to 33 to 35 degrees centigrade, or approximately ambient temperature. The pile has shrunk to about 1/3 of its original volume. Different materials in the substrate or mixture are no longer recognizable. The color is dark brown to black. The material has a humus-like appearance and texture. It should be crumbly or loose. It has an earthy smell or humus odor, and it should have no foul odor. The composting product may be applied in ornamental plants, backyard gardening, landscaping and greening programs. Take note that the quality of compost products depends on the materials used and observance of critical parameters of the composting process. It should undergo appropriate testing and analysis before it can be used for plants intended for consumption. For commercial production of compost, please check the Philippine National Standards for Organic Soil Amendments. This PNS on soil amendments shows that compost for commercial production should be analyzed for basic property parameters, pathogens, and heavy metals, and the product should meet the allowable levels. The PNS for organic soil amendments can be downloaded online. Here are the needed materials during composting operation that you can consider in budget planning. Aside from the composting machine, you will also need a shredder. Common garden tools and supplies. Very important, of course, is the PPE or personal protective equipment. You will also need documentation supplies, and personal hygiene supplies. A mechanized shredder is needed to cut the waste materials into smaller pieces to help hasten the composting process. A multi-purpose shredder applicable for wet and dry organic wastes is recommended. A mechanical or digital weighing scale can be used for weighing the waste materials to be processed for composting. A dial thermometer is used in composting to monitor the temperature of the mixture or pile. Here are other needed materials and supplies. Shovel, rake or fork will be used for mixing of initial composting materials, and for turning of compost pile during the curing stage. A compost sieve for sifting out big, undecomposed particles from the final product before they are packed and stored. Pails or drum containers for waste collection and storage. Water sprinklers for applying water into the mixture or pile to maintain the appropriate moisture content. Sacks for storing the final product, and labeling supplies such as tape, scissors, and marking pen. Documentation supplies such as record book and pen, for recording all the details of composting activities. Personal protective equipment or PPEs needed during composting operation include gloves, masks, goggles and boots to minimize exposure to potential waste's health and safety hazards. Workers should also wear proper working clothes, that is, long sleeves and long pants. Alternative to long sleeves or working shirt with arm cloth. Cleaning tools are needed for regular cleaning and maintenance of the composting facility and used tools and materials. To keep the composting tools and area clean. This may include broomstick and dustpan, rags, detergent, disinfectant, and scrubbing pad. Finally, personal hygiene supplies such as soap, tissue and alcohol should be available for HE workers. When choosing a location and setting up the composting facility, here are a few important considerations. The composting facility should be located away from residential areas. The distance from human settlements and source of drinking water or wells from the composting area shall not be within 5 meters. The composting facility for bioreactor unit should have at least 120 square meters with enough space for workers to move around during composting operation. The area should be secured and covered to protect the equipment and tools, preferably with concrete floor and not prone to flooding. There must also be electric and water supply in the facility. The bioreactor requires a 220-volt outlet. For manpower, at least 2 to 3 workers can be designated to operate the bioreactor composting technology. Here is a recommended layout for the composting facility. The process flow should be carefully considered from the entry point of the waste materials, up to the storage of the end product, for better workflow and personnel movement within the area. The facility should have the following parts. Material or feedstock preparation area where you do the shredding, weighing, and mixing of organic wastes. In-vessel composting area where the composting unit is loaded with the prepared biodegradable wastes. Curing area where the harvested raw composts are piled for further degradation and maturation. Screening and packing area where the mature compost is sieved and packed, and finally, the product storage and exhibit area. In addition, a washing area should be put in place for water supply and regular cleaning. Here is the composting facility in Marikina City. Shown here are their composting area with 500 kg per day capacity bioreactor, the curing area with cubicles and ordinary piles, and the storage area. And here's the composting facility in Barangay Balancas, Valenzuela City with their 500 kg per day capacity bioreactor. Their curing area has partitions for separating the piles, and they have an exhibit area for showcasing their final product. Here's the list of bioreactor adopters nationwide. As of January 2020, we have a total of 121 adopters, majority of which are local government units. Some adopters are food processing industries and private farms. We have 4 licensed accredited fabricators of bioreactor composting technology. We have Lamaco in Bacoor, Cavite. Marinas Technologies Incorporated in Pila, Laguna. Pimentel Creative Buildings and General Services in Zamboanga del Sur. And Bestmark Agro-Industrial Enterprises in Santa Barbara, Pangasinan. The estimated cost for fabrication of bioreactor unit. The 500 kg per day capacity bioreactor is about 625,000 in Luzon, and about 645,000 in Visayas and Mindanao. While the 1 ton per day capacity bioreactor is about 1.2 million in Luzon, and 1.22 million in Visayas and Mindanao. Please contact our accredited fabricators to get an updated cost.